In 2013, astronomers reported that they'd found what was, at the time, the biggest thing in the known universe. It's a collection of quasars about 9 billion light-years away, appropriately named the Huge Large Quasar Group. And some scientists say that it's impossibly big. Like 3 times larger than anything that could ever exist in our universe. When you look up at the night sky, it probably looks like there are about the same number of stars in all directions. Sure, some regions are a little denser or a little sparser, but in theory, you could divide the sky into squares so that each square had about the same number of stars in it. The cosmological principle applies that idea to the whole universe. If you broke the universe up into big enough cubes, each of those cubes would have about the same amount of matter in it. Mathematicians have used the cosmological principle to predict that there shouldn't be any collections of matter, or spaces between matter, bigger than about 1.5 billion light-years wide. So if you made your cubes with sides 1.5 billion light-years long, they should have about the same amount of matter in them. And for the most part, this seems to be true. Galaxies tend to be grouped together into structures smaller than about 500 million light-years. So everything seemed to line up. Mathematicians said there shouldn't be anything bigger than one of those cubes, because otherwise they would look different than the rest, and astronomers hadn't seen anything that big. But in the 1980s, astronomers started conducting surveys of quasars, huge jets of light let out by matter as it fell into the central black holes of galaxies billions of years ago. By looking at where quasars were, they could get an idea of how galaxies in the early universe were spread out. And they noticed that quasars were often bunched together, just like galaxies are today, into what are known as large quasar groups, or LQGs. Some researchers think that these LQGs could be the roots of today's superclusters, which can contain thousands of galaxies. Large quasar groups could have anywhere between 2 and 20 quasars in them, and they could be up to hundreds of millions of light-years across. And in the 1990s and early 2000s, a couple of LQGs were discovered that were about 2 billion light-years wide, making them a little bit bigger than the limit imposed by the cosmological principle. Then, in January 2013, astronomers announced they'd found the Huge Large Quasar Group, or Huge LQG. Its 73 quasars are an average of 9 billion light-years away. And it's raised a lot of eyebrows, because it's a whopping 4 billion light-years across. That's 3 times larger than mathematicians said anything in the universe could get. Some scientists think that the discovery of the Huge LQG means that there really is some large-scale structure in the universe that we can't ignore any longer. But many aren't so quick to jump ship, since the cosmological principle underpins a lot of our understanding of the evolution of the universe. Some question the methods of the original team, and say that there just isn't enough evidence to know for sure that the Huge LQG is actually a collection of quasars and not some sort of statistical blip. Others say that the quasars might be farther apart than the original researchers thought, which might split up the Huge LQG into a bunch of smaller, plain old large quasar groups. But earlier this year, one group of scientists, including some of the discoverers of the Huge LQG, claimed that it isn't necessarily a violation of the cosmological principle after all. They say that 1.5 billion light-years isn't some sort of hard limit. Instead, there's just a low probability of finding anything so large. But it's not impossible. There might be as much as a 19% chance of finding something even bigger than the Huge LQG in our universe. And those odds aren't that bad. In fact, astronomers might have already found something much bigger than the Huge LQG. Something called the Hercules-Corona borealis wall, a group of galaxies that was discovered just a few months after the Huge LQG. And it might be twice as big. Just like with the Huge LQG, scientists are still debating whether this structure really exists, or whether it too might be a statistical blip. But that's a story for another episode. Thanks for watching this episode of SciShow Space, and thanks especially to our patrons on Patreon who help make this show possible. If you want to help us keep making episodes like this, just go to patreon.com/SciShow to learn more. And don't forget to go to youtube.com/SciShowSpace and subscribe.
Vapor coming out, like Enceladus's tiger stripes. The surface module would set up camp on the moon's surface and be in charge of generating power for the second robot, the descent module.